Alright, so our question is, the RL circuit shown has a switch closed at time equals 0. So part A says, what is the time constant of the circuit? So to find that, we use the time constant equation, which is L over R. We have 30 millihenries over 6 ohms given by our circuit here, and that gives us 5 milliseconds. Part B says, what is the current as a function of time flowing in the circuit? So the first thing we did was we just found what the Imax was using Ohm's law, V over R, which gave us 1.5 amps. And then we, so that's actually for the but so this part we're going to do Imax times 1 minus e to the minus t time over the time constant. So that gives us this function here, which is 1.5 amps times 1 to the minus e to the minus t over 0.005 seconds.
And then finally we want to find what is the voltage across the inductor at time 5 times 10 to the negative 3 seconds. So first you find the current going through. So we know the current going through is going to be 1 times 5 times 10 to the negative 3 over 0.005. So that gives you 0.948 amps. Knowing what the amps is going through at the time, we can then use voltage times resistance to find the voltage drop that's across the resistor. And the current voltage drop across the resistor is going to be 5.688 volts. And then through making a Kirchhoff's loop, we can start at the battery, go all the way around the resistor back to the battery, and it all equals 0. We know it's going to be 9 volts minus 5.688 volts, which is going to be 3.3 volts. And it also coincides with voltage of the inductor is equal to the inductance times the time rate of change of current, which is 30 millihenries times the time rate of change, which we found in doing the 1.5 amps minus 9.48 amps divided by 5 times 10 to the negative 3 seconds, which is still 3.3 volts.